Hello everyone. Today we are learning flood fill algorithm. It is a core concept in computer graphics and vision for area filling, segmentation and graphical transversal. The first we are learning is introduction and applications. Second, four connected pixels. Third, eight connected pixels, their comparison and drawbacks. What is flood fill? The seed filling method. The flood fill algorithm is fundamentally used for filling a connected area of pixels with a specific color or pattern. It operates on the principle of connectivity to define the region to be filled. It starts with a single pixel known as seed point. It checks the color of the seed point, the odd color. It recursively changes the color of all adjacent pixels that also match the odd color to a new fill color. The flood stops when it encounters a pixel that is not a odd color or a boundary. Some real world applications. First, image editing. The primary use is the Paint Bucket tool in all major graphic design and editing software to quickly recolor large and contiguous area. Second is game development. Used in games like Minesweeper, revealing colored areas and match 3 puzzle games, grouping and removing connected colored blocks. Third, image segmentation. Crucial for computer vision, used to identify, isolate, and analyze connected regions of interest in scientific or medical imagery. Second concept is four connected pixels. The four connected method is the simpler form of connectivity, checking only neighbors that share a common edge with the current pixel. The neighbors checked are north, south, east, and west. Diagonal pixels are ignored and are not considered part of the connected region. It's generally faster to compute due to fewer checks and may leave uncolored gaps along diagonal boundaries. The logic behind four connected algorithm is recursion, where the function call itself on the four valid neighbor coordinates. This process is repeated until the boundary is reached. The pseudocode for four connected pixel is given here. It is written in C language. Now, 8 connected pixels. The 8 connected method expands the connectivity criteria to include all neighboring pixels, whether share an edge or just a corner. It checks the 4 direct neighbors and 4 direct neighbors. This ensures a more complete fill and is necessary for shapes with complex or thin diagonal structures. The trade off is slightly increased computation time due to checking 4 additional pixels for every single point. The function signature remains the same, but the internal logic is adopted to perform all 8 checks on neighbors before returning control. This is the pseudocode for 8 connected pixels written in C language. Comparison between them. In 4 connected pixels, 4 horizontal or vertical neighbors are checked. In 8 connected pixels, 8 horizontal, vertical, and diagonal are checked. Performance in 4 connected pixel is simpler and marginal faster for simple shapes. In 8 connected pixel, more complex and resulting in slightly slower execution. Coverage in 4 connected pixel may leave gaps along diagonal boundaries. Coverage and accuracy in 8 connected pixels provides complete coverage for all polygon shapes. Some alternative approaches and optimizations ask first scale line fill, an iterative optimization that fills contiguous horizontal segments, only pushing the next segment seed pixel to the stack. This drastically reduces calls and is such a friendly. Second, iterative BSF DSF. Using an explicit stack DSF or queue BSF to manage unvisited pixels. This avoids the risk of system level recursion stack overflow for very large regions. Third, boundary fill, a related algorithm where the process fill continuously until a specific boundary color is encountered rather than checking against a uniform odd color for region's interior. Thank you.